homework problem 11.1.7, and it says that a government aviation organization would like to determine if the average number of minutes that a plane departs late differs among airports in 3 major cities. So we have a data link here. So this is our departure data for 3 different cities. And you see here in Excel, I just manually type this in. I could use the icon here to export it if I wanted to. Not much data, so just easy just to type it in myself. And so that is set, and we are looking at performing a one-way ANOVA. Notice there's 3 levels, 3 categories, 3 cities, with an alpha of 0.05. And we're asked first to define what the null and alternative hypotheses are, and these again are pretty easy with ANOVA. They're always for the null that the population means are equal, and for the alternative they are always that they're basically just not equal, or we could say that at least one mean is not equal to the group. So we need to perform a test for the test statistic, and we want to also determine the p-value. And we can do these things pretty simply with the data analysis Toolpak. So single factor ANOVA, one-way ANOVA. And in our box here, we need to adjust the range, which include the column titles or labels that's activated there. We've got an alpha of 0.05, that's correct. And output range, anywhere start at 813 is fine, or actually I might even just move it up a little bit, 810, and just click OK. And there is our output. So there's our ANOVA table, and you can see it gives us all the details that we need for this particular question, asking us for the F statistic 4.15, that is here. Let's go ahead and highlight that. And also asking for our p-value, which you've given to us there. And this question, unlike question 1, it is not asking for the F critical score, but we do have that if we need to interpret it as well. So pretty simple. We can use either to make a determination about the null, being that the F stat is greater than the F critical value, we would reject the null in that case. Or we can use the p-value approach. The p-value is less than alpha of 0.05. So using the p-value approach, we would also reject the null. So here's where it becomes a little bit more complicated, and that part B wants us to do a comparison test. So here we need to use the Tukey-Kramer test to test the each pair. So again, with ANOVA, the test is telling us if there is a difference in average means with the samples given. So in this case, we've rejected the null, so that we know that the means, population means, are not all equal, but we don't know which ones aren't equal. We don't know if the city 1 versus city 2 is equal or not equal, or city 1 versus 3, or city 2 versus 3. So we don't know which combination or which set of pairs are equal or unequal. That's why we're going to do the Tukey-Kramer test, but not something we can do with the data analysis Toolpak. It's something we need to use XLStat for. So no problem, we can get the same information that we just got here with XLStat along with the additional stuff that we need. So we will go up to the XLStat application, modeling data, and ANOVA. Before I do that though, one adjustment I need to make, if you saw the question 1 video, with XLStat I need to add an extra cell, kind of a title cell if you will, right here in the upper left of our table. So here we can name it anything we want, the problem name, whatever it is. I'll just put airports, because that's the factor that we're studying is airports. So I'm going to have that there, and then I will do the XLStat modeling data, go to ANOVA, and so our table has been selected correctly already in the data table. Range here, we want the output to go on a separate sheet, so it's easy to just toss out if we need to. And our levels, we are using 3 levels because there's 3 different cities. And actually, I apologize, it has defaulted to the question 1 problem. So what I need to do is go back to general. And so a good example, if you are using the same sheet to work some different problems, I need to clear that out. I need to go back to our current problem, which is the airports problem, and reselect the data cell range. So it is here, the airports. Okay. Number of factors is 1. Output range still is a separate sheet. And for options, we need to make sure our levels, again, our categories matches our number of. See if I can take me back to that same problem again for some reason. There we go. And all this stuff is not checked, which is good. Analysis of variance. Now here's one difference, is that when we go to the means tab, the means tab under the outputs, so outputs, general, we have analysis of variance, and means, we are going to use the pairwise comparisons, the 2-key option here. We need to do multiple comparisons. It's a multiple comparisons test, and I'm going to apply to all factors. And we want to use the pairwise comparison as a 2-key comparison. And you can see the drop down here, there's actually quite a few more than that, but this is what we want to use. And so we should be good to go. If I go over to the graphs or the charts, everything should be unselected. I'm just going to hit OK. Okay, and then we see here. Again, XLStat is going to provide more output than we certainly asked for this question, but our analysis of variance or ANOVA table is always going to be a separate set of the data here. So I'm going to highlight that, and you can see it matches what we had before. So we've got our F statistics is the 4.15. We have our p-value of 0.043. Again, if we needed the critical value, we could just use the Excel function for that, the f.inv.rt. Probabilities are alpha, and we have our degrees of freedom here. D sub 1 is 2, D sub 2 is 12. So again, if we needed our F critical value, we would have it. So what about the second part, part B of the question, where we need to do some multiple comparison tests? So part of our output that we selected in XLStat was to provide that information to us, and that's down here. Just highlight that a little bit. And in this table here, we can see the comparison of city 1 versus 2, 3 versus 1, 3 versus 2, and that's exactly what part B is asking us to interpret for the question. And really the section that we want to look at is, well, for this question, it's these two boxes here, the standardized differences, which is noted here in the problem, versus the critical value, CR here. And we could also use, of course, the p-value approach as well. And you can see here with XLStat, it's actually giving you the significance result as well. So we can just look at the yes-no comparisons here and just know, just looking at it right away, that the only one that is significant, meaning that it's the only one of the pairs that we can reject the null and determine that the means are different, is between cities 2 and 3. So, but if we were going to use the standardized differences versus the critical value, we would interpret it the same way we would with the f-test, in that the standardized differences here between 2 and 3 is greater than the critical value, so we would reject the null in that case. And also with the p-value approach, being that the 0.04 p-value is less than alpha of 0.05, we would reject the null in this case as well. And with the other two comparisons, the other two pairs, we would not be able to reject the null in these cases because the standardized differences is less than the critical value, and also the p-value is greater than the alpha. And that's for both pairs cities 3 and 1 and city 1 versus 2.